starting back on number 16, it wants us to find the center and radius of the circle. So what we have to do is complete the square a couple times. First thing we need to do is group our terms together. So I'm going to rewrite this with a little gap. So x squared minus 4x plus blank. And then I'm going to write plus y squared. So I'm just rewriting this with a blank at the end. Okay. And now, here, the way you complete the square to find the center and radius of the circle is by taking its negative b, so you do negative b, or b over 2 squared, not negative b, I'm thinking the vertex form. B over 2 squared is what you're doing. So right here, to go here, I'm doing negative 4 over 2 squared. Negative 4 over 2 is negative 2. Negative 2 squared is 4. What I do to one side, I have to do to the other. Here, 6 over 2 squared. 6 over 2 is 3. 3 squared is 9. What I do to one side, I have to do to the other. So when I write this guy out then, if I write this out, now I can factor this over here. So one thing we'll go ahead and do, let's go ahead and add this together. 3 plus 4 is 7, plus 9 is 16. And now, let's factor out this guy right here. What adds to negative 4 and multiplies to 4? Well, that's x minus 2 times x minus 2. How else could we write that a little shorter? X minus 2 squared. And that's the whole point. That's why we did that random b over 2 squared thing. That allows us a factor here, like a number that works out pretty, that lets us write it as a squared term. Because remember, it's always going to be x squared and y squared in parentheses for a circle equation. So right here, the way I'm going to write this guy out, what adds the 6 and multiplies the 9, that's going to be y plus 3, y plus 3, and I'm going to bring down my 16, so I can write this as y plus 3, oh, not 13, y plus 3 squared. So remember, my center of this circle comes from parentheses or liars. So my center, instead of x is negative 2, the in parentheses there is 2 and negative 3. So we're saying parentheses are liars, x here and y here, okay? And then remember the radius is the square root of this. The square root of 16 is 4. So the radius is 4. So the radius, because this is radius squared at the end. So describing the end behavior here, one thing that I will say is based on if this is positive, so if this is positive, this function, because this is odd, is going to look something like this, okay? Let me give you a couple different examples. So this one, because this is positive, and because this is odd, it's going to look something like this right here, roughly, like at the end, okay? If this was negative, so let's do it in red. If this was negative and odd, this would look like this instead. Now, let's do a different function, say. Let's do it in blue. Let's say my function was y equals 3x to the 4th, okay? That's just all it is. Because this is positive and this is odd, I mean even, so positive and even, it's going to look something like this. And if it was negative, so say y equals negative 3x to the 6th maybe, since this is negative in front and even, it's going to look something like this. So let's describe what's happening here in our original function. in this function, as x goes to negative infinity, so basically as x goes to the left, because negative infinity is this way. So as x goes to negative infinity, my function is going down. So my function, f of x, is going to negative infinity, okay? And if it's going right forever, so if it's going right, so if it's going to infinity this way, my function is going up. And you could use this to figure out what the rest of these would be. So solving the rational inequality, we already did this already, but we'll do it really quick. You would create a sign chart once again. So that is x equals -4 and x cannot equal 5 or does not equal 5. Create my sign chart. If I do this, -4, I'm a 0 there. It doesn't really matter because I don't have a line underneath. I don't have an equal to. I have a 5 here, and I do not equal it. D, N, E. It's good for you to get 2 sign chart practices. Probably going to be on the test if I had to guess. So if you plug in values that are before, between, and after, possible values you could plug in would be, let's say -5, 0, and 6. If I plug that in, let me see. If I plugged that in, not really trying to solve that out. Give me 1 second. Your sign chart should give you positive, negative, positive, if I'm not mistaken. So from here to here, so this first interval, I want positive values, right? I want to be greater than 0. I'm getting that from here. Greater than 0, so I want positive values. So my first interval is here, so from negative infinity to -4. There's no equal to underneath, so I use parentheses, union, and then 5 to infinity. So 19 is a little deceiving, okay? 19 is a little deceiving. There's actually a 7-step process that you've got to do with this one. The first thing it asks is even, odd, or neither. And it'll ask it in a different way. Remember, even means there's y-axis symmetry. Odd means that there is origin symmetry, and obviously neither means there's neither, okay? And for 1, the way you tell this is the exponents, because remember, this is x to the 0, x to the 0, okay? So this guy right here, this is a 2, so my exponents, let's highlight them. I've got 2, 0, 2, 0, okay? That means that I have all even exponents, so it is an even function, which means it has y-axis symmetry, okay? Second thing it asks is the y-intercept. Remember, that means plug in x equals 0. If I plug in 0 to this, I can plug it in, let me erase this. So if I plug in 0 right here for x, that's going to give me 0 minus 1, 0 minus 4, or let me just write it out. So y equals 0 squared minus 1 over 0 squared minus 4, which is just positive 1/4 if I type it in. So I've got a y-intercept at 1/4. The third step is the x-intercept. You set numerator equal to 0 and solve. So if I do that, I get x squared minus 1 equals 0. There's a couple ways you could do this. I like to factor, so x squared plus 1, minus 1 factors to x plus 1 x minus 1. So I have x-intercepts at x equals -1, comma 1. So, because I get -1 from here, 1 from here. Okay? And I'm going to erase these guys here. Boom, boom. Just so I have room. So my fourth thing is going to be the vertical asymptotes. So the fourth thing is the vertical asymptotes. And what that's going to look like here is I'm going to have vertical asymptotes. They happen when denominator equals 0. Okay, so they happen when the denominator equals 0, because in our class we don't have to worry about wholes. So I say x squared minus 4 equals 0. And one thing I will say right here real quick is on 3, you only have to type in this list. Okay, so -1, comma 1. But here, actually, I'm going to need to write it out. So this factors to x plus 2, x minus 2 equals 0. And one thing I will say is you need to write it as x equals -2, comma x equals 2. Don't forget the x equals. Do not forget it. Okay? Don't forget x equals. So, because a vertical asymptote is a line, like it's a line through there. So the horizontal asymptotes, there's a couple cases we've got to consider. I know this problem's a lot, but I guarantee it's going to be on the test. So, 5 is the horizontal asymptotes. And that happens, like, in Ural's case, the only thing you got to check is check the highest exponent in numerator and denominator. If same, y equals leave over leave. If different, y equals 0. Okay, that's how I remember this. So I check the highest exponent. Okay, what's this highest exponent right here? The highest exponent on both of these is 2. So because it's 2, I just do the leading coefficient, the number in front of x squared, right here, so 1 over 1. So because they're the same, I do y equals 1 divided by 1, which is just y equals 1. And once again here, don't forget y equals. Because it's a line. Asymptotes are lines. But now, when it's saying it's different, because in our case, I'm just simplifying it, but in our case, let's say that this was just x, like x to the 1. If they're different, we're just going to say that it's y equals 0, so I would just put that. So the sixth thing, it just has you plug in points to check. You just plug those in with your calculator, and then let me show you what this would look like in a graph. So y equals, let me remember what the problem was, x squared minus 1 over x squared minus 4. And this does have a couple things going on. There's that axis across the y-axis, like it would fold across the y-axis nicely, which is good. So we said we had horizontal asymptotes. I mean a vertical asymptote at -1. No, it was -2 and x equals 2. So that's what this would look like on yours, but these are the dashed lines. So this is what this looks like for you. Like if you're going to draw a graph of this, it would look something like this, and y equals 1 and a dashed line. Okay, so if I drew this out, this is what this function looks like. My vertical asymptotes that I found, x equals -2. It's a vertical line, vertical asymptote. That's what it means. It's a vertical line through x equals -2 and x equals 2. And the horizontal asymptote is a horizontal sideways line through y equals 1. 20. So this one's kind of weird. Pay attention to how it's worded. Y varies directly with X. So that means as Y is equal to, like as Y changes by something, say K, X changes by it. So basically, if it's direct variation, you just put KX, okay? KX. And inversely means that it's flipped. So it's going to be Z on bottom, okay? Z on bottom. So if it varies inversely with Z, Z is on bottom. And then a variation model then means solve for K, like write a variation model means solve for K and then rewrite. Okay, so if we know that when Y is 12 and K we don't know and X is 6, so K times 6 over 3. We can solve for K. Then divide by 6 on both sides, that gives me 6 equals K. So this variation model means, like, if I rewrite this over here, Y equals 6x over 7. I mean, not 7z. 6x over z. And sometimes you might see the 6 written out front instead. So 6 times x over z. That just means that as y changes, x is going to also be multiplied by 6. Like, as y changes, it's going to change by 6x, and then the z is being divided because it's inversely going the other way. So here, exponential and logarithm functions. So right here, one thing I need to show you is how to write this out. So if I have if I have 5 to the 2x plus 1 equals 125. The way I would go about doing this is doing log base 5 on both sides, because that'll cancel out that, and I have 2x plus 1 equals log base 5 of 125. But the issue is, on these little crappy calculators you're forced to use, you can't type that in. I don't know why it pulls up 100,000 things here. Now, so here, I can't type in log base 5 of 125, but I can do base on bottom. I can change it to log of 125 over log of 5. So instead of log base 5 over 125, I can move base on bottom of my fraction here, type it in like that. So log 125 over log 5 gives me 3. So 2x plus 1 equals 3. Then solve for x minus 1 on both sides. That gives me 2x equals 2. And then divide by 2 on both sides. That gives me x equals 1. Which, if we think about what this meant originally, this makes more sense. So if I plug in 1 into my exponent here, that gives me 2 times 1 plus 1, which gives me 5 to the third equals 125, like we think. Now, to do this kind of problem, 22, if I just have one single log on a side, notice I have log equals some number. So log equals 2. Well, the way I do that is to get rid of log. Remember, if it's log, it's base 10. So I do 10 as a base on both sides. 10 as a base. So this is basically saying 10 to the log power. Those just cancel out. 2x plus 3. And then 10 to the second power is going to be 10 to the second power is 100. If I minus 3 on both sides, I get 2x equals 97. If I divide by 2, I get x equals 97 over 2. So similar thing here is we have to use condensing rules to be able to do this one. And another thing to say is if I have multiple logs, always plug answer back in. So if I have multiple logs, I always need to plug my answer back in. So on this one, it's kind of like a square root or a variable in the denominator. So how do I combine these? Addition becomes multiplication. So I'm going to multiply this in here to combine it to a single log. So log of x squared minus 3x equals 1. And then, once again, this looks like number 22 now. So to get the log away, I do 10 as a base on both sides. So that's going to cancel out. I have x squared minus 3x equals 10 to the 1, which is 10. So this gives me a quadratic. I need to subtract 10 on both sides to get that equal to 0. And then I would factor this guy out, x plus 5, x minus 5, bad math, x minus 5, x plus 2 equals 0. So that would give me x equals 5 and x equals negative 2. So when I plug this back in, I'll get a domain error if it doesn't work. So I'm going to plug in 5 for x and negative 2 for x in separate ones. Okay, let me see. So I'm plugging in log of 5 plus log, why didn't I put the plus log of 5 minus 3, which gives me 1 like I expected. Good. So this guy works. But then when I plug in negative 2, let's just type it in separate. So log of negative 2 plus log of negative 2 plus 3, or minus 3. I get a domain error because right here I would have log of a negative number. Like right here I would have log of negative 2, can't have that. So my only solution here is this one. Keep on trucking. So 24 is just like the one we did at the main beginning of this page. I have log 2 on both sides, so log 2, it's going to cancel out. So I have x plus 1 equals, and remember to type this in on my calculator, I have to do log 16 over log 2. Log 16 over log 2. So when I look at this then, I have log 16 over log 2, which is 4. So x plus 1 equals 4. If I minus 1 on both sides, that gives me x equals 3, which does make sense, right? If I look at my original equation here, if I put a 3 here, that would give me 3 plus 1. So 2 to the 4th equals 16, which is right. So if you look at 25, to expand, if you go to the unit, what is this, unit 4? Yeah, if you go to the unit 4 review packet that I gave you all, I put all of the expansion rules and condensing rules in a chart at the main last page. So it should, like, let me pull it up real quick. The main last page of that big review packet. Let me see, where we go. Yep, so right here, a quick reference at the main back of unit 4. It's right here to help you remember. So to expand, we want to expand, that gives me multiple logs. Like I want to end up with multiple logs, okay, most of the time. So when I have one log, I want to expand to multiple logs. So the way this works is I've got to split up everything. Remember, the top becomes plus and the bottom becomes minus. So this becomes log of 5 to the log base 5 of 3. I'm splitting that apart from the x squared. Plus log base 5, because I'm using the base 5 because they have base 5. Log base 5 of x squared minus, that's what I mean by the minus. So a minus goes in front, log base 5 of y cubed. So if I move the exponent to the front, I get log base 5 of 3 plus 2 log base 5 of x minus 3 log base 5 of y. So my order there, I broke it apart with this plus and minus rule. And really multiplication becomes addition. Division becomes subtraction. Or the top becomes plus, the bottom becomes minus, the numerator becomes plus, denominator becomes minus. That's how I remember in a shorthand way. We break it up to this, and then we further break it apart. The front moves to the exponent moves to the front. And if this was a nice number like log base 5 of 5 and it gave me 1, I could simplify. But log base 5 of 5, if I try to type that in my calculator with base on bottom, log base 5 of 5 would be log of 3 over log of 5. That's not a pretty number, so I'm just going to leave it like that. So condense, that means go down to a single log. And once again, I cannot reiterate enough, doing this alone is simply not enough studying. Like, this material is not enough. You need to be working on more of this on your own at home, like the test packets. But this is a good help, a good start. So 26, if I'm condensing, remember the front, I go front to exponent first, so the front moves to the exponent. So that gives me log x squared plus log y minus log of z. And then addition becomes multiplication, mama, is how I remember that. So addition becomes multiplication, so I have x squared y minus log of z. And then subtraction becomes division, so I have log of x squared y over z as my final answer. Okay. And then for the 27, a sum of 5,000 is invested in at a 6% interest rate and compounded quarterly. Find the amount after 5 years. So it'll usually give you the formula. It should on the test. But this is A equals P1 plus R over N to the NT. Remember, P is the amount I start with, my principal. This is also in the Unit 4 packet, should be at least. And R is my rate, and N is the number of times it compounds, as T is how much time I leave it in years. So if I plug in here, I'm investing 5,000, and I've got 1 plus my rate as a decimal, so 0.06, and it compounds quarterly. How many times is that going to happen in a year? N is how many times it compounds in a year. Quarter, there's 4 of them in a year, so 4 is N. So 4 times my time it stays in is 5 years. 4 times 5. So if I write that out, I get 5,000. 1 plus 0.06. 4. So A equals 66,734, and we're working with dollars, so we're going to round to the nearest cent, so 0.28. The amount is that right there. So, last page. Solve the system. Easiest way I would do this would be to solve it via addition. Just to show you the way, like a way that will work if this doesn't work here, is just to go ahead and get a variable by itself. You could use elimination if you feel comfortable with that, but let's go ahead and get a variable by itself. I just want to show you a couple of different ways. If you see elimination, you can go ahead and do that, but let's go ahead and get this one. Let's get y by itself. So that gives me y equals 7 minus x. Okay, y equals 7 minus x. So we're going to plug that into y here. So that gives me, if I write it over here, 2x minus parentheses 7 minus x. I'm plugging in for y. That equals 1. If I distribute the negative, I get this, and then combine like terms. So 3x minus 7 equals 1. Add the 7 over. This one doesn't work out super pretty, but that's okay. So 8. Yep. And then if I divide by 3, x equals, and then I plug in that x value for y here. So I've already got y by itself right here. So let's just plug it in. So y equals 7 minus whatever my x value was. So 8/3. If I type it in my calculator, so y equals 13/3. So my answers go x comma y, so 8/3 comma 13/3. 29. This one already has y by itself, so we can just plug this one directly into it. So I get 3x plus 2 equals x squared minus 2. Get the left side equal to 0, so minus 3x. There's nowhere to put it over here, so I'm just going to write it here. Then minus 2, minus 2. So that gives me 0 equals x squared minus 3x minus 4. That's going to factor out to x minus 4, x plus 1. Which gives me x equals 4 and x equals -1. I plug both of these back into either equation, doesn't matter the top or bottom. The bottom looks simpler, so I'm going to plug into that. So I'm going to plug this in right here. So y equals 3 times 4 plus 2. That gives me y equals 12 plus 2, which is y equals 14. So one answer would be x, so 4 comma 14. And then another answer, if I plug it in to this one, would be, so let's plug it in right here, y equals 3 times -1 plus 2. Type that in, and it gives me -3 plus 2, which is -1. So -1, my x, comma -1, my y. Here we have y by itself already, which works nicely, so we can plug it in to y squared here. So we have x squared, let me extend this down, x squared plus parentheses x plus 2 squared. That's for me plugging in, equals 20. So if I multiply this guy out, x squared plus, oh wait, hold up. Sorry, my brain's just very tired at the end of the day. X plus 2. Right now it's 6:20 after school on Monday, so I'm pretty worn out. So if I multiply that out, I'll have my x squared drop down from the front. And then in blue, what this multiplies to is x squared plus 4x plus 4 equals 20. If I combine like terms, I get 2x squared plus 4x plus 4 equals 20. Then if I come down here and minus the 20 to get the right side equal to 0. Then I can do AC method to factor this guy out. Remember this here, 2 times negative 16 is negative 32. So what multiplies to negative 32 and adds the positive 4 here? That would be, so I'd write 2x squared, and then what does that is positive 8x minus 4x minus 16. So AC method. So now I can group these guys. These have 2x in common. And these have negative 4 in common. And that'll leave me with x plus 4 equals 0. So that ends up being 2x minus 4 and x plus 4 equals 0. So if I set those equal to 0 and solve, 2x minus 4 equals 0. If I add 4, that gives me 2x equals 4. Divide by 2, I get x equals 2. And then here, I just get x equals negative 4. Parentheses are liars. I just flip it real quick. So these are my two values to plug back in. And once again, we have an easy equation for y. We know that y is equal to x plus 2 from the top equation. So let's plug in. So let's plug in first here. So y equals 2 plus 2. So y equals just 4. So this first answer would be 2 comma 4. And then this guy right here would be y equals negative 4 plus 2, which is negative 2. So negative 4 comma negative 2.